CO2 can only be drawn down by natural forces. There's no magic vacuum cleaner out there that's just going to pull it down for us. We must work in conjunction with nature. Doesn't matter how much we reduce our emissions, we still have to pull down what's there or global warming will continue to increase. Bamboo is a climate change hero. Diameter, it takes about 2 months to reach its full height. And then it takes after that 3 years to mature. So you're only harvesting 25 to 33% of each plant in any 1 year. That leaves the roots and the majority of the culms to hold back erosion, which makes it particularly wonderful for growing along rivers and on steep hillsides. Bamboo also balances the microclimate because of its mass. Square miles of abandoned croplands. That's nearly 7 times the size of Texas. Bamboo can grow on abandoned and marginal lands that cannot be used for agricultural purposes, meaning that it is a biomass crop that will not compete with food. It also produces food at the rate of 1 ton per acre per year. There is a lot to love about bamboo. What would it take to make farmers in the tropics and subtropics spontaneously plant more bamboo on their marginal lands? And the answer is, give it a good market price. Tie it to the world economy. So what would tie bamboo to the world economy? Making it a designated biomass that replaces fossil fuels. And then, of course, people will plant it. There's a new cutting-edge technology that can convert bamboo biomass to carbon-negative biofuels. It's called Paralysis. There are 7 different types in the world. We prefer the auger style. It can take bamboo biomass, run it through a machine that can be put into high-cube 40-foot containers and shipped any place in the world, plugged together in a plug-and-play sort of system that can then start producing not only thermal energy for industry, but also electricity, biofuels, and most importantly, biospheric carbon for millennia. It's a powerful soil amendment. It increases water holding capacity. It retains nitrous oxide in the soil. Nitrous oxide is 210 times as dangerous as carbon dioxide. It rejuvenates soil life. It increases food security, it increases beneficial microbes, and those microbes further sequester carbon in the form of glomalin via the liquid carbon path. Biochar sequesters carbon for 1,000 years. That is 85% pure carbon. It was once in the atmosphere. Now it's sitting in a form that will sit in the soil for over 1,000 years. The reason biochar is so effective is because it has a very high surface area that allows microbes, particularly mycorrhiza, to live. Mycorrhiza is a microbe that grows in combination with 90% of all plants. It's a symbiotic relationship in which the plant over-photosynthesizes by 40 to 50% and exudes those carbohydrates down to the mycorrhiza. The mycorrhiza then go out into the soil and bring back nutrients that the plant would otherwise not be able to get. When there are drought conditions, mycorrhiza can go out and bring back water. But perhaps most importantly for climate change, mycorrhiza sequester carbon in the soil through a system of taking the carbohydrates given to it by the plant and turning it into glomalin, which is what gives soil that wonderful tilth, making more room for additional water to soak in when the rains are heavy rather than rolling down to the valley. So this glomalin is a form of carbohydrate in the soil. In soils that are farmed sustainably, it has been recorded as much as 32 tons of carbon dioxide have been sequestered per year per hectare. So the system is this. The CO2 goes into the bamboo. It also goes into the ground under the bamboo. Some bamboos are nitrogen fixers, as well as the companion plants that are also nitrogen fixers. The bamboo is used as a biomass that goes into pyrolysis that produces electricity, thermal energy, bio-oil, and biochar. The biochar is put on agricultural fields that then increases their crop yield, and that additional increase goes into under the bamboo, and the bamboo biomass itself that becomes biochar. In the soil under the agricultural fields and in the biochar that comes from the resultant increased biomass from the crop fields, and then also